We are Entras. Together, we build software for controlling flexible assets for the industry.
We strongly believe that the future will be flexible. Any industry, big or small, any building, any home, will make use and make profit out of flexibility.
That future starts now. In this podcast series, Flexing the Future, we share our insights on flexibility.
Welcome in our podcast Flexing the Future. I'm Frank from Entras and our guest today is Helena Gerard from VITO. Welcome, Helena.
Thank you.
Could you quickly introduce yourself and VITO?
Yeah, so my name is Helena Gerard. I'm a senior researcher in the grids and energy markets team of VITO. VITO is the Flemish Institute for Technological Research, and we are performing research in different activities from biology, materials, but also energy. And in particular for energy, VITO, together with our partners KU Leuven, IMEC and University of Hasselt, we are together in the collaboration EnergyVille. And we're located in Genk, and there we're performing energy research.
All right. So the goal of the podcast today is to talk about the Galileo Project. What is the Galileo Project about?
So the Galileo Project, it's a project, let's say in one sentence, it deals with industrial flexibility. But where did it came from? So it's funded by the Energy Transition Fund. So that's a funding mechanism from the federal government. And we started maybe 1 year and a half ago. We were discussing with a couple of industrials, and they all had the same issue. They were ready to do something. They were ready to electrify. They were ready to decarbonize, but they didn't know how to. They were really looking for some hands-on insights between all those numerous options that existed. So we were thinking, yes, let's try to do a project that can help industry, but maybe not only industry. Also the grid, we have been seeing that there are a couple of challenges ahead in the energy system, transmission grid, distribution grid. So also there, if we could connect this industrial flexibility to the challenges of the grid, Galileo could be a project. And maybe just one word on the name. Why then Galileo? Exactly because we wanted to give some more insights on those options. We were thinking, Galileo, it's also the navigation system. The name of the navigation system. So how can we support to navigate industry towards all those options? And of course, how to do that? We wanted to do that with a quantitative approach. And then we were also looking at the name of Galileo, who was one of the most famous mathematicians. So that was indeed, the name was born, and then the project, it came as a logic consequence. Yeah,
and then from Galileo, you tried to explain, this is now the abbreviation of...
So the project indeed, it deals with, it's a long abbreviation. It's maximizing the potential of industrial flexibility and supporting the competitiveness of the Belgian industry. So 2 axes. One will deal with flexibility, more the short-term part, and another axe that will deal with energy procurement and smart hedging strategies to lower the energy cost where possible.
Yeah, and I just want to go back to, as the origin of the project was a lot of industrial parties that want to move forward with flexibility, but they could not go alone, or they did not find their way. How would that be possible? Do we have an answer to that?
Well, that was exactly the starting point. They observed a lot of barriers. And those barriers were not like often was thought in the past. This is just a matter of technical issues. When we can go for more automation, this will be solved. But it's way more complex than that. There are not only technical barriers, there are also a lot of regulatory hurdles. It's very complex. Regulatory hurdles at European level, but also at Belgian level, but even at Flemish level. And then a third axis is that the business cases that they observe or that they need to establish to go for a specific investment, those business cases are not very stable, and there were many more barriers. So it became clear that the complexity, but also the interplay of all those barriers, it was not easy to have one easy solution. And that often a combination of hands-on research, but also technical research with those partners, together with interactions with policy, were necessary to come to more, I would say, more integrated solutions. And that's a bit what Galileo aims for. It's an integrated solution by working not only in silos, but by really looking for synergies between academics on the one hand, service providers on the other hand, and the industrials. So you have this triangle of very applied research and fundamental research as well, combined with, I would say, solutions that really work. For example, the work that Entras is doing, the academic and the fundamental research, more VITO and KU Leuven, and then together with the companies, and that triangle then should leverage and should give us, I would say, concrete results.
Yeah, all right. So the other industrial partners are, if I'm not mistaken, EPRM, a steel producer, Nirstar, zinc producer, the Tiense sugar refinery, sugar producer at the Sendelo Group. They produce fertilizer, PVC, gelatin, and a lot of things. And then a data center. Is there some common denominator for all those parties, or are they really different? How is...
Very good question. And actually also one of the main aspects that we would like to discover within Galileo. So we have 5 sectors involved. And obviously, we have the chemical sector, steel sector, data sector, but also food sector, metallurgic sector. Those are, in principle, very different. But what we were observing was, for example, if we look at how to establish a business case and how to bring more certainty into your investment, in particular with respect to what are future revenues for flexibility, those sectors observe the same barrier. So the idea of Galileo would also be to make a distinction between what are typical barriers that we observe linked to an individual sector, or maybe in some cases even to an individual technology, compared to those barriers that are more cross-sector. Yeah. And also to make that clear. And that also means that maybe in some cases, companies from very different sectors could actually observe the same problem, but also could benefit from the same solution and learn from each other. And that interplay between sectors, which is naturally not really done because industry is often very much organized according to sectors. You even see it now with the new European plans for supporting. It's all based on individual sectors. We also want to do this cross-sectoral collaboration and integration. Yeah.
All right. And another remarkable partner of the project is Elia, the transmission system operator. What is their role in the project?
So one of the main objectives of the Galileo project is obviously to unlock industrial flexibility. But of course, unlocking industrial flexibility, you do that for a certain purpose. And the purpose in this case, it's the grid, and then with a high focus on the transmission grid, so high voltage, and to a certain extent, medium voltage grid, which is under the which falls under the distribution system operator. Why is that? So transmission system, in particular, with the shift from classic production towards more renewables, there is a need for more flexibility, but not only more flexibility, also different kinds of flexibility.
Different flexibility. Yeah.
So this flexibility should, for example, be quicker, more often available, more dynamic. There are a lot of specifications. And the idea would be that, first of all, we try not only to unlock the industrial flexibility, but that we also map exactly those characteristics of the different processes on the future needs of the grid. And here the word future is very important, because indeed today you see already quite a lot of system services in the market. So today it's already possible to provide flexibility and to get a remuneration. But the idea of the project will also be to be sure what in 10 years? Because if an industrial today is doing a certain investment to make sure that he will be more flexible in the future, this is of course not something where they expect only revenues for the coming 6 months. This is an investment where they would like to have, at least for the coming 5 to 10 years, stable returns. So therefore, we also want to give a vision on the future needs of the grid. And that's also something where Elia will support us.
Yeah, okay. and stability of investment is not only the markets, but also the regulatory framework around it and the policies.
Yeah, and indeed, and that was at this moment one of the most important insights already. This stability of investments is a major blocking factor. Mm-hmm. And even now, with all the new state aid options, where you could say, there is additional money coming in to do those investments, but if your future returns and revenues are vague, unclear, or there's a lot of uncertainty, also the risk remains too high. So it will be double. We need to support the investment and the cash out today, but we also need to make sure that at least the uncertainty around future revenues, that we make that as low as possible.
Yeah, that's a difficult one, I think. So, but for flexibility, you have like the industrial sector that could implement more flexibility. That's all about the project. You have also the smaller contributors like households and very small companies, and we see that all those groups are more and more on the path towards more flexibility. So one of the big questions is where will these markets go to, and also the certainty of revenues from those markets will depend on the parties that participate. If a lot of companies focus on residential flexibility, if a lot of batteries are being built which are in essence flexible, at least on short term, then I can easily understand that the industry has big question marks if they want to do an investment which pays back in 5, 6, 7 years, that I see a lot of risks.
Yeah, that's absolutely one of the main challenges that we're now facing, and where it's very important to establish a robust business case. Because indeed, not only you will have new services coming in, transmission and distribution grid with certain requirements, you also have a lot of new flexibility providers, a lot of new different technologies. And consumers on the one hand, but also typically batteries. It's now a technology which can be quickly deployed. It's very flexible. It can provide a lot of different services. The question will be, those industrial flexibility, where will it position in the merit order? Because that's also important. It's not sufficient that you can say technically this industrial process is capable of providing a specific service. If the cost of doing so is higher than another technology, then it's clear that this industrial flexibility will barely not be used. And then the revenues were, for example, overestimated. So that's also something that we are now exploring, is to look at what are all the different services and all the different flexibility sources, and then try to map them, looking also at their cost, but also at the requirements. What are they capable of doing so? You can imagine that some flexible processes can react very fast.
Yeah.
And that you can also be very exact in planning. For some grid needs, this is very important, where the reliability, of course, if you look at end consumers, will be different.
Yeah, I can add in our own research at Entras that we see that the time aspect of flexibility is really important. And then you kind of have industrial installations that can react very quickly, within seconds or minutes. That might then be very useful for the ancillary services, and because they are about restoring the balance on a very short time frame. But then we see other processes where you can they have storage inside the process, and they can shift production from the week to the weekend. They produce more during the weekend. They have a lot of storage, and then they can produce less during the peak hours during the week. And so then we see this different time scale, but what we also think is the let's say the size of the different flexibility markets is important here, because the ancillary services, they have, let's say, a rather limited size in Belgium. Let's say order of magnitude 100, 200 megawatts, something like that. But then the day-ahead market, which plays day-ahead, where you could see flexibility as going over, also within one day, but also going over a few days and maybe a week, the volume is more like so the order of magnitude of 10,000 megawatts. And so a question is how will that play, and where can industry link in?
Yeah, also there. So indeed, there is an entire spectrum of different system services. You actually also have the very, you could say even services linked to security of supply. For example, then we talk about CRM mechanisms,
yes,
which is also a sort of flexibility, but that's different. And that will be a big capacity, which is available only when it's really needed.
Yeah, protection of the society
Exactly.
effect. Yeah.
So, but that's also one type of flexibility where some industries could say, yeah, I don't want to provide flexibility on and off, but in case it's needed and the remuneration is high enough, I might be available. So that's already one more long-term view on flexibility. And then indeed, you arrive at the day ahead and the short-term services for, on the one hand, energy optimization. Then we talk more about day ahead intraday, but also then the real system services for flexibility or for the transmission grid. Then we talk about frequency containment reserves or frequency restoration reserves. But next to that, you also have congestion services.
Yeah.
Today, they're not necessarily branded under the umbrella of a specific flexibility product, but that will also come.
Yeah, that's coming.
And this congestion, again, you can see it at all voltage levels, so high, medium, and low voltage. And also there we will see products which are more long-term, short-term, together with day-ahead time frame, or very close to real time. So there is really a patchwork of different services, different products, and different time frames. And typically, dependent on the industrial process, it might fit better in one of those categories. There will be a lot of potential on the day ahead, because there you're completely right. The depth of the market of the day ahead optimization is very big compared to those system services. And there is the planning element, which is very important. And it also came back as a main barrier for industrials. Often they are still very much organized according to a clear production plan. So if suddenly, because you would offer flexibility, you need to change the plan, it's not only a technical question, you also have an impact on the operational functioning of the plant.
Yeah.
If you do a day-ahead optimization, this is something which is way more under control. And for some industrials, this will be the key.
Yeah.
For some others, when the process is highly flexible, also highly automated, and when it's more like push the button, then obviously they can also function very well in those close to real-time processes.
Yeah, indeed. Also, in our own projects, we have seen that. To give some examples, we had a company, they were drying stuff. So they have let's say a belt, and then they need heat to dry a lot of stuff that comes from food and feed materials. And there, the question is always on how much heat do you need, but you can influence the process by varying the speed of the belt. If you push quick, then you need to insert more heat. The heat is then made with gas or electrical boilers. And then if you push the slow button and the belt goes very slowly, then you need less heat at that moment. And then first we thought, they would not be interested, but this will heavily impact their operations. But the staff that was working there, they thought, we can gain savings on our electricity bill or energy bill, the total cost of energy, and they were prepared to look at it. And then we saw that you have incoming material, so if you push up the belt speed or you put it down, then the incoming flow needs to be able to adapt, and also the storage before the production line and after the production line, you have the same effect. If the belt is going quicker, then you need enough storage to be able to store it. If it's going slower, you still need to be able to serve your customers. And they were quite keen to discover how that could work into the operational process. Now, we also see a lot of customers who say, the production line will not be touched. They produce, for instance, cookies. which need to be baked. And that process is very tightly monitored because they want the best quality of products there. And they were not prepared to change anything about speed and so on. But then we saw, but you need heat as well, and you have buffers. And then for this particular industry, but that has to do with operational decisions, I guess, and quality decisions, they came to the conclusion that, if we have enough storage in our buffers, you can use the buffer capacity to play on the energy markets. And then you see that it are comparable processes. They both work with an automatic flow of product. And one company says, we want to adapt. The other company says, no, the belt speed cannot be changed. And so you need to solve a puzzle to see what kind of operational flexibility is acceptable to the staff and will still create enough revenues for them to go forward.
And there you touch upon two very interesting barriers that also came back as major results from the first 6 months of the Galileo project, because what we did was going in depth in discussions with those industrial companies, part of the project, to really try to put examples on the different barriers, to make it very concrete. And one very important barrier, which is even more important in the talks we had with companies compared to literature, was product quality. There is, and it's logic, there is a certain pride for the product that they're making, and they don't want to mess up the quality by providing services to the system. And product quality, it became very obvious for a company like Tiense Suiker. They're in the food sector. So product quality, it's extremely important. Also, you're there with a food process. So you cannot mess with some of those parameters, because there are some chemical processes behind that just tell you this is the time that you need to process part of the input material. But it's not only for the food sector, also for the chemical sector. Examples from Tessenderlo Chemie also showed very clearly that they have a lot of interconnected chemical processes. So even if one individual process could provide flexibility, you always need to take into account that you will have some byproducts that also have a connection or that are an input for another process. And not necessarily for Tessenderlo, but often also for other companies in their value chain. So it's very interconnected. And the quality is key. And secondly, next to the quality, it's also the engagement of the people on the floor. And that was also something that also in discussions with other industrials became a difficult one. There was a lot of resistance. There was fear in terms of, shall we be capable of maintaining product quality? But also, how will this impact the way that we work, our internal processes, the different roles that we have within a factory? And this is also something that we hear often, that this change management, in order to overcome this initial, it's not necessarily resistance, maybe it's kind of a fear or what will happen, because what we're doing now, it works well. If we change now, what are the implications for process and people? This is something that needs to be monitored, and is probably not often sufficiently recognized if we look at those new plans from the regulatory side.
That reminds me of a very funny discussion that I had. I was at a seminar for planners, because I wanted to explore, can we talk with planners, production planners, industrial process planners, can we talk with them? Because our flexibility story and planning seems to be closely intertwined. And then, so they gave seminars about planning, and then one of them raised the question, they have the feeling we make a planning, and operationally it does not work. So they were discussing how can we help operation staff to follow the planning. And they were discussing about it, and then they said, but the most important thing is the money we lose if they do not follow the planning, because they produce products that will stay in store forever or that are not needed, and we do not produce the products that the customers want at that moment. And so their conclusion was, we should kind of make clear what the amount of lost money is, because the fact that operations doesn't follow the planning, like 1 million or something in a week. And they were all convinced that would convince the operational guys to adapt. And then I had some talks with them about energy. And then, of course, planning, it's logical that maybe it's the nature of any human being. You look for stability. And energy flexibility does not increase stability. It could, but normally people expect we will have fluctuations and the planning will be more difficult. So I was talking to them, I was explaining, and in the end I was saying, yeah, but do you realize you can do small changes in your energy systems or in your operational processes that can also lead to millions of cost savings, depending, of course, on the energy consumption of the company. And then they said to me, but Frank, that wouldn't work. The planning is very important. If you say us, we will lose millions, that will not motivate us to use flexibility. And I said, but I found this remarkable because they just said we are going to motivate operation staff by saying you lose so much money and then operation staff will listen. I say exactly the same thing to them. If you make your planning more flexible, then you can save millions. And they said, yeah, that will not motivate us. And then I was a bit in the understanding what the difficulties of human nature to introduce new concepts. And everybody thinks of his or her own island. And they want to keep that stable and they want to improve it. But this energy flexibility thing is really a multidisciplinary domain. It's markets, it's planning, it's operations, it's even maintenance.
Yeah.
And so it's I think a rather let's say a difficult issue for our industries and the people that work there.
We actually also asked the question to some companies who are successful in providing flexibility and also changing their internal processes. And one that was more like a dry best practice, the answer was you need to have the right KPIs. A plant functions according to KPIs, and often a KPI is on process efficiency, but it could also be on product quality, on outages, even on the number of people that are on time on their in the factory to perform a specific activity. There is today not necessarily a KPI on the amount of flexibility offered to the grid. So that was one option. Obviously, that's not changing everything because then you come into discussions like you had, which you will not solve with KPIs. And then some other companies said, yeah, but we started to actually give trainings on energy, on the energy transition, very high level, very broad, and to everybody. From the people of the accounting department, to the plant managers, to the marketing guy, everybody involved. And then we were building that up. Every session became a bit more narrow. And in the final session, the question was, how can we as a company contribute to those bigger societal challenge? And then suddenly people felt like, yes, we need to do something. And they also felt they were proud because their company could also do the good things. And they were an essential part of doing the good thing. And that was an entire trajectory of multiple months, multiple sessions to really get everybody on board, not necessarily for a very concrete, let's provide industrial flexibility with process X, Y, Z, but how can we contribute to the energy transition? And it's a bit fluffy, but it seems that for the change management, in order to be efficient and really taking place, this is also needed. In addition, of course, to changing some technical elements, making sure that a business case and investments are sound, and obviously also that the regulatory environment is also in support of the activities that the company is doing.
Yeah, because if you look from a distance, flexibility is something that makes money. It's something that for society will introduce the possibility of much more renewables without too much other difficult investments. and in the end, it reduces the CO2 of Belgium, of Europe. So from a distance, you would say this is so logical. Why do we even need projects to think about it? That's a big a dilemma.
Yeah, and you also see a difference between companies. You have companies where the management has this entire integrated vision on, okay, we want to decarbonize, we want to electrify, we want to be a sustainable example within our sector. And there, often the change management happens really driven from a top-down vision and strategy of the company. That's not yet the case for each industrial company that we observe within Europe. And there they see that if suddenly the energy manager comes and says, we can provide flexibility, there is a business case, there are some additional revenues. If it's not embedded in an overall strategy, first of all, the people on the floor, they don't buy it, but also the management. They just look at it as a pure business case. They see all those uncertainties in terms of revenues. And they say, maybe not for us. Of course, they are now forced by the regulation. They need to do something. They need to go for more decarbonization, more electrification. But you see that it's somehow with the brakes on. It's not yet a full commitment. So it also maybe means a bit of change management at the top of some of those industrial partners. And we hope, for example, with a project like Galileo, we have those committed companies on board that they can also be a best practice for other peers within Belgium, but for sure within Europe, to show how this change management can take place and what it can mean for a company. And that they also observe barriers, but that for each barrier, there are solutions.
Yeah, I heard it as well. Some companies are quite opposed to flexibility because they feel it as they are forced into it. And that's a bit, let's say that's a bit of a pity, but of course they're not forced into flexibility. Other things are being put into policies, like the obligation to have solar panels and other stuff. And then the consequence is that if you apply flexibility, you will have better control over your bill. But do you think that some industries feel forced to act in a flexible way?
I'm not sure whether they feel really being forced. It's often that they don't really see the added value. And in some cases, it's because they consider, flexibility for our process, we run baseload. No, it's not worth to investigate. So they even don't really think about it. They have already kind of ignored the option. They have put it aside and they really focus on, okay, for our baseload production, we want to have the lowest energy procurement cost as possible. And those additional revenues from providing flex to the system, they're minor compared to our overall energy cost.
They're not substantial enough for them.
Exactly. So that's one. So they're just not interested enough. And then there are others who are now exploring a bit more the option of flexibility. They might maybe feel a bit of the societal pressure, like, oh, in theory, you could be flexible. Your peers are providing flexibility. Why are you not yet providing flexibility? But there you see that they often still observe a lot of internal barriers, but also some technical barriers. And they're still a bit in the dark. And they look for guidance. And that's something where I would assume that between now and the next 3 to 4 years, a lot of things will happen because this guidance is there. There are a lot of other peers that could provide examples. There are consultants, researchers that can help those industrials. But that's a bit the tipping point where we're now.
And the same parties, I hear them often say, the big batteries are coming. The very big batteries, the capacity is going up. And that will kill the value in the flexibility markets.
Yeah, it's often a concern. But then I always say the following. We are talking about batteries already for a long time. And then a couple of years, all batteries were providing FCR, so frequency containment reserve. And the idea there was, this market, it will be
Gone.
completely for batteries, it will be gone. So then there was a big shift towards EFRR, so a different type of flexibility. Now, batteries can also provide, in principle, this service. But a couple of years ago, we said, no, batteries, that's FCR. Now batteries are EFRR. Batteries will for sure play an important role, but it will not be enough. And there will also be different types of flexibility services coming, where batteries are less suited. In particular, if you need to have flexibility for a longer time than a couple of hours, batteries are not your best option. And that's something where we'll also look at to those patterns. Maybe industrial flexibility will play an important role, for example, in the day-ahead optimization, but also if you need to have a longer time between a longer period of flexibility, let's say up to 6 or 8 hours. So yes, there will be a place for industrial flexibility compared to batteries, but it's for sure something that needs to be assessed. But also to connect to that, batteries are not something which is completely separate from industrials. A lot of industrials are now considering to also install batteries on their own site, in particular in support of their own processes. But then, of course, those batteries they have invested in, they can also provide part of the flexibility. And often in combination with an industrial process, you have actually a real power couple. So that's also something where the technology of a battery should be seen differently from only, I would say, portfolios of batteries providing services.
Yeah, indeed. Yeah.
And that's also something that we see, that a lot of industrials, they're not only looking at the flexibility from their existing processes, they also consider investing in new technologies like e-boilers, but also investing in, for example, batteries and even on-site windmills. So there is a lot of, I would say, variety that we see, and also a lot of options of optimization on the industrial side where they can kind of leverage on different sources of flexibility and then submit that or use that to provide services.
Yeah, and if I link back to something you said earlier, let's say the growing capacity constraints of the grid and the higher possibility of congestion problems, and with this kind of technologies, they could prevent the need for a higher connection by introducing this kind of technologies into their process.
Yeah.
And then it really helps them to grow without the fact that the capacity might not be able to be increased by the grid operator.
You touch upon a very important aspect. We have maybe not underlined it enough. So that's the grid. And obviously, flexibility can provide services to the grid. But at the moment, the grid is also seen as the major bottleneck for a lot of electrification trajectories of different companies. That also means that within, for an industrial, if they can already incorporate flexibility in the design of a new electrification process, so then it's really designed for flex. It's not looking at, we have done the investment and now what is the flexibility potential? But no, you already integrate flexibility in the design. You might ask for a lower connection, or you can actually accept a flexible connection, which could be the solution of compared to a situation where, unfortunately, the grid operator needs to say, I'm sorry, your electrification process is not possible because we need to reinforce the grid, and that will take 5 to 10 years.
Yes.
So to that extent, flexibility is not only a solution for the existing grid problems, but it's also a solution for in case that the grid is a bottleneck to do this electrification investment.
Yeah, and we're just at the beginning, I think, of this, let's say, it is a problem, we can say that. And where you see that in the Netherlands, they are far more into this problem of grid congestion. And the question is, when will Flanders be in the same position? Or if it ever comes, of course.
Yeah, you also see there that indeed the congestion problem in the Netherlands, if you look at the congestion map, in particular for the medium voltage, it's we can say it's dramatic. So it's we are luckily not there yet. In Flanders. But it means that there is also no time to waste to develop the solutions that can prevent that we come in the same, I would say, problematic situation. Obviously, there is also a difference between low voltage, medium voltage, and high voltage, and the congestion arises also from different sources. And for example, if we now look at the transmission grid, for Belgium, we will have a lot of connections needed for the offshore wind park. So that's also a typical thing, which is obviously not relevant for the lower voltage levels. Okay. But also at the level of the transmission grid and also the interconnections between countries, there will be congestion because there will be more renewables, there will be high capacity. Also, if we look at Germany, at the typical Dunkelflaute. So that means that also the more that we can be flexible on the transmission grids, the more we can actually prevent that we come into situations of very high prices to solve a certain problem. No, that's for sure. But it needs to happen now and not tomorrow.
Yeah. And if we zoom out to the link between everything that has to do with flexibility and the competitiveness of our industry, how do you see that?
Yeah, it's. I would say it's one-on-one linked. You also see it in the most recent regulatory proposals to support industry. We have the Clean Industrial Deal at the European level. We also have, of course, the decisions taken at federal level by the new government. We have now also a Flemish industrial plan. And you see there as one top priority is making sure that for industry, the cost of energy goes down. Obviously, the cost of energy, you could also look at it, can we also increase the value or additional revenue streams within their energy portfolio management that could also lower that cost. So not only looking at, we need to, for example, have lower procurement cost or a different hedging strategy, but if we can make sure that they can offer flexibility and they get a high value for that, it's an additional revenue stream that will also lower the bill. Yeah. And that might, in some cases, be very profitable and requires less of an investment than purely focus on lowering down the initial procurement cost of baseload.
Yeah, all right. We see it as well as a kind of protection against a cyclic economy. Yeah? So when the economy is down, the big companies, they produce not anymore at 100% load, but typically lower, 90%, 80%. I heard 70 and 60% even recently. But of course, this kind of lower load of an industry allows for a lot of more flexibility actions. If they're always at 100%, there is less possibility to do flexible stuff than when you're on average at 60 or 70%. So we see that as a kind of a hedge when the industry load is low and in a bad economic situation, they could make a lot of more money with flexibility. So it kind of protects them at the low times of the cycle, and it protects them to be ready when the cycle gets high again.
And also an important element is that's more systemic, that if more flexibility from industry is in the system and it can support the grid at a lower overall cost, obviously also the typically the network tariffs might expect to go down. And that's a very significant component these days in the energy bill of large industrials. Yeah,
all right. So it will certainly help competitiveness. I would like to conclude, Helena, with a final question. What changes do you think will be inspired by the Galileo project?
What I really hope is that by making some of those barriers very concrete, not just on a paper, but really providing examples where in this industry is really having an issue up until the nitty-gritty detail, something you never read in a paper, but is the true reality, that you can bring this true reality more clear towards policy, so that they also tackle or support industry in removing those barriers. So that's not just a top-down vision on state aid and regulatory reforms, but to also create the environment to also tackle very operational and change management elements.
Yeah.
And if the Galileo project can bring these things up and make it visible towards also peers in the sector and policy, then I think we have done our job.
Okay, now we are at the end of our podcast, Helena. So thank you for sharing your insights on the Galileo project, and thank you for being here.
It was a pleasure.